Welcome to Chapter 6. We're going to be talking about ratio and proportion. And these are actually both ideas that you have already had experience with. And you'll see in just a second why that's the case. So let's dive right into 6.1. What is a ratio? Well, basically, a ratio is a fraction. And it's a relationship between two numbers where we are comparing them such that their relationship is effectively division. We are comparing them and contrasting them in such a way that we write them as division. And so you'll see exactly why that's the case soon. But let me just show you quickly kind of what we mean. So let's look at something like, let's say you've got a recipe. And the recipe calls, here's our recipe. The recipe calls for 1 cup of flour and 2 cups of milk. Let's just suppose here. And so if you went into the fridge and you saw, oh, well, I have a certain amount of milk, then that could be the limiting factor. And the relationship is that you have to have 1 cup of flour for every 2 cups of milk. In other words, you have to have half as much flour as you do milk. And as long as you maintain that ratio, then your recipe will come out okay. Right? But if you don't obey that ratio, then the recipe doesn't work. And so recipes are all ratios. They're fractions, they're proportions, they're relationships where we're comparing two quantities such that we can think about division, like this case here. Now, there's a couple of different ways you can write it. You could say something like this exact ratio. You could write 1 cup. If you were to write, here's what we want to do. We want to write the ratio of flour to milk. So there's a couple of different ways we can write this. We can write it with the word to. So we can write 1 cup to 2 cups. And I can drop the units and just focus, since they're the same units, right? The units actually don't matter in this case, because whether it's 1 cup to 2 cups or 1 tablespoon to 2 tablespoons, if I make a really small version of the recipe, as long as the relationship, the proportion, the ratio remains the same, then it's okay. So I could write it with the word to, so there's one option. Another option is I could actually write it with a colon, 1 to 2. You'll see this a lot when it comes to things like odds in the world of sports or betting. You'll often see ratios expressed like this. And then another way you might see it is as a fraction. And that includes all the different ways you could see a fraction written. So that's what a ratio is. It's just a fraction. So you have had experience with it before. And now we're just going to apply it in some different contexts. So we looked at an example from cooking. And here's an example from kind of our standard algebra text. Let's write the ratio of 2/3 to 4/9 as a fraction in lowest terms. So the first thing we want to do is recognize that a ratio is division of two numbers. In this case, the two numbers are fractions. So we're going to have a complex fraction, but that's okay. We're just going to reduce it. So instead of writing it with the word to or with a colon, I'm going to write it with a fraction bar. And I write that fraction bar a little bigger than the other fraction bars to signify You can see over here, it's a little bit thicker. This one is a little bit thicker and wider than the other fraction bars to signify that it's the primary operator. And so then I'll rewrite this as division with the division symbol because it makes it a little clearer, actually. I could have done that from the beginning, but I think of ratios as fractions, and so I like to write them. I like to write them as fractions, and then I recognize that I have a complex fraction, so I have to write it as division of two fractions, and then I can copy dot flip, or I can multiply by the reciprocal of the second fraction, of the denominator fraction. So now I could multiply straight across, or I could reduce. And so I recognize here that I have some common factors, top and bottom. So when I go to multiply here, I'll have 2 times 9 over 3 times 4. And so I can see here, 3 goes into 3 once and into 9 3 times. 2 goes into 2 once and into 4 2 times. And so 2 and 4 have a relationship. Their ratio is 1/2. 2 to 4 is 1 to 2. And so I can simplify to 1 to 2. And now I can do my math here. 1 times 3 is 3. 1 times 2 is 2. And so then the simplified, reduced version of this original ratio is 3 to 2. So hopefully that makes sense why we need to reduce, because complex fractions are, as the name suggests, complex and are hard to interpret. But something like 3 to 2, that makes a lot of sense. 3 to 2. So for every 3 of this, I have 2 of that. That makes a lot more sense than the original ratio that I was given, even though it has the same relationship. Okay, let's have a look at another one. So here's a chart where we've got a bunch of different ratios on the left written with the word 2. Then we have them expressed as a fraction, and then we have them reduced to lowest terms. So you can see here the first one, 25 to 35. So we write that as a fraction. And then we say, well, 25 and 35, what do they have in common? 5. 5 will go into both of them and reduce them. So 25 divided by 5 is 5, and 35 divided by 5 is 7. So 5/7. And we can do that for all of our ratios. One thing that's interesting is if we look at something like the second one, 8 to 2, 8 to 2, right? 8 to 2. It reduces to 4 to 1 because, 8 and 2 are both divisible by 2, and 8 divided by 2 is 4, and 2 divided by 2 is 1, so 4 to 1. So we can write this as just 4. That's true, but if it were a recipe, it would still be wise to write it as 4 to 1 because you want to make sure that whatever that 1 is, in this case, if it's say a cup of milk or a cup of flour or a cup of sugar or whatever it is, needs to be accounted for. So just something to keep in mind if you see a ratio and it reduces to a whole number, keep in mind the context, whether it's appropriate to write it as a whole number or whether it's appropriate to keep it as a ratio of something to 1. Okay, here's a kind of an application problem. So there's a solution of alcohol and water. There's 15 milliliters of water and 5 milliliters of alcohol. So if I draw a little beaker here, then 15 mils of this is water. So 15 mLs of H2O, and then 5 milliliters, so 5 ml of alcohol. So I'll just put AL. Well, I'll go ahead and write it out. It's a little small, so you can hardly see it, but it's there. And we know, so there's 15 mils of water and 5 mils of alcohol. So in total, there's 20 mils of liquid in this beaker. So if we want to write ratios, we need to know what it is that we're comparing. So in this case, they want us to write the ratio of alcohol to water. So alcohol to water. So the order matters. So alcohol is 5 mils and water is 15 mils. Then, once we've written it as a comparison with 2, then we can write it as a fraction. And then whenever we write a fraction, it's always important for us to look, the onus is always on us, to look to see if we can reduce, if it makes sense to reduce, and if we can. So in this case, both these numbers end in 5, so I know they're divisible by 5. So I'll start with that. 5 divided by 5 is 1. 15 divided by 5 is 3. And so 1 to 3. So 1 parts alcohol to 3 parts water. Then look at the next one. The next one is the reverse. We want to compare water to alcohol. So then instead of 5 to 15, we're comparing 15 mils to 5 mils. So it's 15 over 5. And when we reduce that, we get 3 over 1. Now notice we're not going to write this as 3. We're going to keep this as 3 over 1 because it's important that that 1 mil for every 3 mils of water, that 1 mil of alcohol, it's very important that that be accounted for. So we're going to leave this as a fraction in this case, and we're going to resist the urge to reduce. So hopefully that shows you an application. And let's have a look at this review. So in your own words, write a definition for the ratio of two numbers. Well, in a word, fraction. Right? A ratio is the fraction of two numbers. So wherever you see ratio, you can read fraction. What does a ratio compare? A ratio compares two numbers. So it's the fraction of two numbers. Now, typically these have the same units, but they don't necessarily have to always have the same units, as we'll see going forward. What are some different ways of using mathematics to write the ratio of A to B? So you could write it A to B. You could write it A colon B. You could write it A divided by B. Right? And D. So when will the ratio of two numbers be a complex fraction? Well, the ratio of two numbers would be a complex fraction if either number in the ratio is a fraction. Then it'll be a complex fraction. And you'll have to do some work to simplify it, make it look a little better, make it look more aesthetically pleasing and simpler, just like you have to do whenever you encounter a fraction. So that's the basics on ratios, 6.1. Hopefully that gets you started, and we'll see you in 6.2.